Hello friends, in this video, let us learn how to analyze an algorithm. Generally, two major factors are used to analyze any algorithm. One is time, that is, how much time an algorithm takes to produce the desired output. And the second one is space, that is, how much memory space the algorithm consumes to produce the desired output. So first, let us understand how to analyze the time complexity of an algorithm. So the time complexity of an algorithm depends on various factors such as machine architecture, that is whether the machine is a 32-bit architecture or a 64-bit architecture. Then on the processor that the machine has, that is the machine can have a single core processor or multi-core processor. Then it depends on the execution type. That is, the machine can execute instructions one by one, sequentially, or it can execute multiple instructions parallelly. Then, the time complexity depends on the machine's memory access time. That is, how fast a machine can read or write data to or from the memory. And the last one is what input we are giving to a particular algorithm. And when we analyze the time complexity of an algorithm, we do not bother about all these factors such as machine architecture, processor, its execution, etc. Because these are machine dependent factors which may vary from machine to machine. So in general, we analyze the time complexity of an algorithm based on the given input. That is, for a given input, how much time and space the algorithm takes to produce the desired output. And every machine is unique in its own way. Some machines can have sequential execution and some other machines can have parallel execution. And we can't analyze the algorithm for every individual machine. So let us first build our model machine to analyze the algorithms. And our model machine will have these features. It is a 32-bit architecture machine. It has a single core processor. It will execute instructions sequentially, that is, one after one manner, and it takes 1 unit of time for the basic operations like read, write, assignment, and return statements. For example, the instruction int I equal to 0 takes 1 unit of time, and the statement return 0 also takes 1 unit of time. So these kind of basic operations will take 1 unit of time. And to make the analyzing even simpler, we can make the assumption that every simple statement takes 1 unit of time. For example, this is a statement with 3 assignments, but still we can assume it takes 1 unit time as it is a simple statement. See another statement here. Here we have multiple arithmetic operations, but again by our assumption it takes 1 unit of time. Similarly, this statement will also take 1 unit of time. So that is our model machine. Now, let us analyze the time and space complexity of the swapping algorithm with our model machine. First, let us talk about the time complexity. First, we have temp equal to A. And this is a simple statement. Hence, it takes 1 unit of time. Next statement is A equal to B. Again, it is a simple assignment statement. So it also takes 1 unit of time. The third statement is B equal to temp. Again, it will take 1 unit of time. So what is the total time taken? It is T of x equal to 1 plus 1 plus 1. That is, the time complexity function T of x equal to 3. Which means, whatever may be the value of x, the T of x function will remain in some constant value. Say this graph. For every value of x, the T of x value remains constant. So we can call this algorithm as a constant time algorithm. So the time complexity of the swapping algorithm is order of 1, which means the time complexity does not depend on the given input in this algorithm. It will remain constant for any given input. In general, we use this big O notation to represent the time complexity. But we also have other notations like theta, omega, etc. We will learn about them in the coming lessons. So that was the time complexity. Now let us discuss about the space complexity. In this swap function, we have two parameters, variables a and b. So let us say a takes 1 unit of memory and b also takes 1 unit of memory. Then, in the first statement, we have temp equal to a. That is, there is a new variable other than a and b. And it will also take 1 unit of memory. And the next statement a equal to b, and we have already taken a and b, so there is no issue. And next we have b equal to temp. Again, both b and temp are already considered. So that's all. So the total memory taken by this swap algorithm is 1 plus 1 plus 1, that is 3 units of memory. So space complexity S of x is equal to 3, which is also a constant. So this algorithm takes only a fixed amount of memory, and the space complexity is order of 1. So that was the time and space complexity analysis of the swapping algorithm, which is a very simple algorithm. And we got time and space complexity is equal to order of 1. We will discuss more complex algorithms and its analysis in the coming videos.